Okay, today what we're going to do is day 14. Figuring out the context. Okay, so today in class we worked on interpreting the remainders. That's kind of just like what we're going to be doing right now. And I really want to explain to you how this works. Now, you may have it with you, you may not. Some of these work and some of these don't work. This isn't really you have to figure out one for each one. It is which one did you use for the answer. So we're going to start out with a small number. Say there are 14 people. We have 14 people and they are going to be playing Xbox. Say they're playing Mario Kart on Xbox. We know on Mario Kart or Wii or Nintendo 64 or Nintendo, we know when you play Mario Kart you can only play up to 4 people. Okay, so only 4 people can play. 4 people per game system. So if we draw out 14 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We want to see how many groups of 4 we can make. So the 14 dots represent our 14 people. And what we're trying to figure out is how many game systems we need. We know how many people can be on a game system, but we're trying to figure out how many game systems we actually need. So the problem looks like this: 14 divided by 4. So I can draw this out and say 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I have 2 left over, so I can't make a group out of that. So if I did 4 divided by 14, does 4 go into 1? It does not. Does 4 go, how many times does 4 go into 14 without going over? Well, I know my facts are 4, 8, 12, 16. 4 goes into 14 3 times. 3 times 4 equals 12. Okay, so that shows right here 3. 1, 2, 3. And I have 2 as my remainder. So if the question said, how many full games, full game systems were there, the answer would be 3, because these are all full. There's 4 players on each system, okay? So that means what we'd be using is we would be using the whole number only. While there is the remainder 2 here, we don't need the remainder 2 for our answer because it's asking how many full game systems were there. So we're actually only using the whole number as our answer. If it said, how many were on the last system, or I'm going to put up here how many people. How many people were on the last game system? The answer would be 2. And what we are using is the remainder only. Okay? So we are only using the remainder for our answer for that question. They don't care about how many full game systems there are playing. They want to know how many were on that last system. Now, if it said, how many systems total do they need? The answer would be 4. 1, 2, 3, and then we still need a system for the last 2 people. It's not fair for those 2 people not to play. Now I'm sure you're thinking, oh, but they could take turns. Nope, we want everyone to play at the same time. So we would need 4, which means we are rounding up. Okay? Now, fraction or mixed number, that doesn't work well with people, really. It works best with food, things that you need the exact amount for. Same things for decimals. Normally, if they're asking for the decimal answer, what they're asking for is normally it's probably with a number problem. So, what I'm going to do is on the next page, we're going to look at a problem. Tomorrow in class, what we're going to be doing is we're going to be looking at how to create a problem for, let's see, 1, 2, 3, 4, 5, 6. The same problem has 6 different answers. Okay? Now, I'll tell you, when I was in college, I was a little confused with how you could have one answer always equal, or one problem always equaling 6 different answers. But let me show you how that works. It's quite simple once you think about it. So, say the question is 18 divided by 4. Okay? And we need word problems. Well, let's think exactly, first of all, what the answer is. We could draw 18 dots and make groups of 4. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now I'm going to make groups of 4. 1, 2, 3, 4. So I know my answer is 4, remainder 2. So if they said that you needed to create a word problem that had the answer of 4, we would need to create a word problem where the answer is 4. Well, how do they get the 4? Well, the 4 is actually the whole number. So we need to think of something where maybe something full. How many rows were full? How many full cars were there? Where they want to know the full amount. So we could say, and the thing that's really easy is that we're just changing the names a little bit. So there are 18 people going to a basketball game. Each car holds 4 people. So 18 is my total amount. Okay, and the 4 in this problem equals number of, or we'll say actually equals group size. So there are 18 people going to a basketball game. Each car holds 4 people. How many full cars will there be? Well, if you look here at the picture, you're going to have 1, 2, 3, 4. 4 full cars. You're going to need 4 full cars, but guess what? That's all they're asking for. And guess what? Your answer to this problem is going to be 4. If you're talking mathematically and exact, the answer to just this problem right here is 4 remainder 2. But based off the context of the problem, they wanted to look at that specific answer. Now say they wanted a word problem with the answer is 2. A word problem could be there, the same exact thing, are 18 people going to a basketball game. Each car holds 4 people. How many people will be in the last car? So they don't care how many people or how many cars total they're going. They care about how many people are in the last car. Well, we see the last car will hold only 2 people. So the answer would be 2. Okay? So everything is the same except for the last question. Say they wanted to know the answer is 5. I want you to try to think of a word problem where the answer is 5. Pause the video. Then once you think you have a word problem, if you want to use the same kind of situation, you can. Once you've paused the video and try to think of a situation, I want you to come back to the video and push play and see if you got the same thing. Okay, now that you have tried this on yourself or by yourself, I'm not going to write it down, but what you could say is there are 18 people going to a basketball game. Each car holds 4 people. How many total cars will you need? See, here, the first time they asked for full. Here, they asked for the last car. And then this question could be asking for how many cars total. And you have to round up because you need 1, 2, 3, 4, and then you need a 5th car for these last 2 people, and their car just won't be full. So it depends on the context that they're asking you. Come back with any questions you may have.